Hello everyone. Today we are going to talk about one of the most important device used in modern industries, the variable frequency drive, commonly called in VFD. If you work in maintenance, automation, electrical panel building, or even if you are a student for preparing industrial job, understanding VFD is extremely important. Many people use VFD daily, but very few truly understand what is happening inside it. Some people think VFD just a motor starter. Some think it is only speed controller, but actually this is much more than that. In this video, I will explain everything a simple language, why we need a VFD, how it controls motor speed, what happens inside the drive, how it protects the motor, where it is used, and why industrials prefer VFD over traditional starter. So please watch this video carefully till the end. First, why we need VFD. Let us first understand the problem. The most industries we use induction motor. These motors are strong, reliable, and low maintenance. But there is one limitation. When we connect a normal motor directly to the power supply, it runs at almost fixed speed. It that means whether you need full speed of half speed, the motor tries to run at the same speed. Now think practically. In a pump system, do we always need full of flow? In conveyor system, do we always need maximum speed? In fan system, do we always need air pressure? No. Answer is no. But without VFD, we cannot easily control motor speed. Earlier industries try to control output mechanically. For example, in pump system, they partly close the valve to reduce flow. But what happens? The motor still run at a full speed and waste of energy. So electrically consumption remains high. This is insufficient. So imagine instead of restricting flow mechanically, we reduce motor speed itself. If motor runs slower, pump runs slower, and energy consumption reduces naturally. This is the biggest advantage of VFD. It is gives full speed control, but that is not only this benefit. Another big problem starting method is high current. Sorry, another big problem is starting method is high starting current. When a motor starts directly, it takes a very high current for a few seconds. It creates voltage drop, mechanical shock, stress on coupling, stress on gearbox, electrical stress on cable. VFD solve this all problem by providing soft start. Motor start slowly and smoothly, so mechanical life increases, electrical stress reduced, energy efficiency improved. This is why VFD become very popular in industries. My second point is what happen inside a VFD. Okay. Now let's understand what happening inside a VFD. Even though it look like a simple box with a display and button, internally it is a power electronics converter. First, three-phase supply enter in the VFD. Inside the VFD, the first stage of convert this AC power into DC power. This is done using electronic components that allows current to flow in one direction. So the alternating current becomes direct current, but this direct current is not perfectly smooth. So VFD use a large capacitor to smooth the DC voltage. These capacitors are strong energy and create the stable internal DC supply. This is internal DC section is called the DC bus. Okay. Now comes the most interesting part. VFD the VFD takes this DC power and convert it back into AC power. But this time AC output is not fixed, it is variable. That means frequency of output can be controlled when the VFD changes output frequency, motor speed changes. This is how speed control happens. The conventional DC back to AC is done using fast electronic switches. These switches turn on and off 1,000 times of every second. By controlling how long they stay on off, the VFD creates a controller AC waveform. This is method called PWM. Full form is pulse width modulation. Even though the output is made from pulses, the motor sees it as a smooth current because of its internal induction. So motor runs smoothly. The entire process happens very fast and continuously while the motor running. Okay. So my next point is how VFD control motor speed. Now let's understand speed control in simple language. Motor speed depend on supply frequency. If frequency increase, motor speed increase. If frequency decrease, motor speed decrease. VFD changes output frequency, but there is something important. If we reduce frequency without reducing voltage, motor can overheat. If we increase frequency without proper voltage, the motor may lose torque. Okay. So VFD adjusts voltage and frequency together in balanced way. This keeps motor performance stable, so motor can produce proper torque and even at low speed. This method maintaining balance between voltage and frequency, the basic control method using most application. For normal pump and fan application, this method works perfectly. Okay. So my next topic is advanced control method. In some application, we need very precise control. For example, elevator, CNC machine, cranes, high precision machine, manufacturing. In this casing, simple speed control is not enough. We need accurate torque control. Advanced VFD use more complex control method. This method analyze motor behavior and just adjust current in smarter way. This gives better speed stability, better torque, fast response. These drives are more expensive but necessary precision application. Okay. So my next point is energy saving explanation. Now let's talk about energy saving. This is one of the biggest reason industrial we install VFD. Sorry, this is the one of biggest reason industries we install VFD. Pump and fan system, the power consumption increase very fast with speed. If you reduce speed slightly, energy saving can be significantly. Instead of running motor at 100% speed all the time, if we run at 80% speed when full capacity not need, electricity consumption drop considerably. Okay. That means lower electricity bill, lower heat generation, longer equipment life. Over 1 year, energy saving can be very high. That is why many industries install VFD into all system. Okay. So my next topic is motor protection features. VFD is just not a speed controller. It is also protect the motor. It can be detect over voltage, over current, under voltage, overheating and earth fault. It is if any abnormal condition occurs, the VFD stop motor safely. Traditional starter cannot provide this level of protection. So VFD increase reliability. Okay. So my next point is practical industrial application. Let's discuss in real example. In water treatment plant, VFD control pump speed accordingly to demand. In HVAC system, it controls fan speed depend on temperature. In conveyor system, it adjusts speed of for smooth and material flow. An elevator, it provides smooth acceleration or deceleration. In industries, in textile industries, it controls machine speed precisely. In compressor system, it is adjust speed based on air pressure requirement. Almost every modern factory uses VFD in same way. Okay, so next thumb. Okay, so my next point is installation and common mistake. Many times VFD problems happen not because of the drive but because of wrong installation. Common mistake: poor earthing, long motor cable without proper protection, no ventilation, dust accumulation, wrong parameter setting. Proper installation is very important. Always ensure good grounding, clean panels, proper airflow, correct motor nameplate entered. Okay. So final conclusion. Today we understood VFD is a power electronics device that converts fixed frequency power into variable frequency power. It allows speed control, save energy, reduce mechanical stress, and protect motor. It is one of the most important device in modern industries. If you truly understand VFD, your industrial knowledge become much stronger. If you want a next video on VFD fault and troubleshooting, comment below. Thank you for watching. So, topic is complete. If you like my video, so please like and subscribe my video. Okay. Thank you very much. Thank you.